Hello everyone. Here the question says a galvanometer of resistance G. Okay, a galvanometer is present of resistance G is shunted by a resistance of SO to keep the main current. What is my main current? The current received by the galvanometer is called the main current, that is IG. Let us consider IG. Okay, in the circuit unchanged. The main To keep the main current in the circuit unchanged, the resistance to be put in the series with the galvanometer is. So, what is the resistance need to be put in the galvanometer? First of all, the main current in the galvanometer can be said as. So, I will be taking this. So, galvanometer will be writing like this. So, here only we are going to see about the resistance. So, whatever may be. So, in that you are going to be see the galvanometer resistance. So, the current main current received by the galvanometer is going to be Ig. Okay. Now, the next thing is going to be, now in the second case they have said that yes, we need to add some. So with the shunt only, with the shunt, so here the total current is different than the main current. Okay, this is going to be the shunt resistance is going to be present here. Okay, you should understand this. This is I, the total current is I, the current received by the galvanometer is going to be Ig. Okay, this is a very important thing. So we are, the Ig is going to be unchanged in the circuit. Okay, even this shunt resistance is going to be present here. Okay, the Ig does not change, the main current does not going to be changed. So for that we are going to add some resistance here to equalize these two things. To equalize the shunt and this galvanometer, we are going to add this, so that this, okay, the upper one and the lower, these both are going to be same. So here the concept is that, okay, this is the main concept you need to understand here. This is the main current which is going to be incident on the Ig is the main current. So total current is I. In order to balance it, we are going to add some another resistance here. So here the shunt resistance is there, we are going to add some another resistance. I will be taking as S dash. Okay, so that the current received by this galvanometer is going to be Ig, same as before. Okay, what? Okay, yeah, this need to be changed as Ig remains the same. Okay, so for, yes, so I am just doing here. Yes, this need to be become as Ig. Okay, the received by the main current is unchanged, the main current is going to be unchanged here in this situation. Okay, this is the important concept you need to understand in this situation. So this is going to be Ig, this is Ig. So slowly you have to see this. Okay, so that you can able to understand the concept very clearly. Okay, next I'm just moving on. So whenever in a circuit I will be drawing a circuit right here. So circuit is going to be present like this. Okay, so potential difference is provided here. So here the current received by this both the resistance is same. When the current received by this both the resistance is going to be same, when it will be same. So anyone else, do you know about this, whether this is R1, this is R2? So can anyone say when the current received by the two resistance will be same? When R1 and R1 is equal to the R2, then this thing can be happened. So the current received, the current flows through the circuit is based on the resistance present, resistor which is going to be present in the circuit. Unless as external resistance is added to a circuit, the current does not flow. It depends on the resistance. When they both receive the same amount of current, okay, then they both resistance are going to be same amount of resistance is going to be present in both this case in ohm. Let us say for example, this is, if this is 10 ohm, this is also going to be 10 ohm. Okay, so concept is clear. If the concept is clear, I am just moving to the next page. Okay, So, and again I'm just drawing this thing. So galvanometer, this is resistance in the galvanometer. So this is going to be I will be taking this as Ig. So the same thing, this is in the first case, this is in the second case. I am just drawing here. Yes, this thing is going to be, whenever you are going to take this thing, yes, this is a galvanometer. Okay, here the shunt resistance is going to be present here, right here. So this is going to be Ig here, right here. Okay, Ig, and this is going to be, yes, this is going to be shunt, and here an external resistance is going to be placed to balance this upper resistance. The shunt resistance should be balanced, right? This both join together and balances this thing. Can you able to understand? So for that we are going to add this. So if the current received by this both the situation is same, then the both the resistance is going to be same. So this resistance is going to be, so we can able to get this resistance is going to be G, the resistance in the galvanometer, which is going to be equal to, yes, same amount of current, think, okay, just before we saw this. So this both are in the parallel. So resistance in the parallel Rp is equal to R1 R2 by R1 plus R2, R1 plus R2. Can you able to understand? Just yes, I've just we know that 1 by rp. In order to say the basics, I'll be saying this 1 by r1 plus 1 by r2. So from this thing we are measured this. Okay, we took this. So to find this resistance of the parallel, R is going to be equal to, as R1 is going to be G. Let us look at, this is R1, this is R2, R2, G S by G plus S. Understood? Understood? This resistance. Okay, both join together and form this R, capital R. Okay, now this both resistance are in series. Yes, now it is going to be converted into R. This is R and this is S dash. This in the above the image I am just rewriting the above image. So this both, yes, the galvanometer and the shunt resistance are in the parallel, they join together form R. So R value of R is written here. Okay, right? So when there is a resistor or in the parallel, when they are in series, here in this series, R1 plus R2, right? Whether I am right? So the total resistance present here is going to be, yes, this R. I'm just doing this R here, R1, R2 is S dash. Okay, the total resistance here is R. R is G S by G plus S into plus, sorry, plus shunt resistance. This is the final equation that we get here. From these two things, the concept is very clear. The current received by this both the thing is going to be equal, then the total resistance of this circuit and the total resistance of this circuit is going to be equal. This circuit is just G, and for this circuit the combination of the resistance is going to be present. So for that, this is going to be the resistance. From this we can able to find, we have to find what is the value of S dash. Yes, the main current should be unchanged, so Ig should be remains as it is. For that, how much resistance should be present here? That's what I am trying to say here. Okay, very well, you have to understand this thing. To put this series, okay, what is the value of this shunt, sorry, S dash? So from this you can able to find what is the value of S dash. So just moving this, rewriting the equation right here. Yes, I am just rewriting the equation, choosing the pink color. G minus G S by G plus S is equal to S dash. So whether it is given in the option or C. So option, in the option they are given just the simplification. We have to do the simplification right here itself. So this is minus actually. So by cross multiplication method, so G square plus G S minus G S whole divided by G plus S is equal to shunt resistance. So S dash S dash. Whether you can able to understand this or I have to write again. I will be just showing the simplification also, so that some of the persons who cannot able to understand. So this is going to be like this, right? So G into G plus S minus GS SGS by G plus S. Understood? Cross multiplication has been taken place here. So this is the value we get. This is the value we get. We just cancel this both. G square by G plus S, the correct answer for this question. G square by G plus S can be written as S plus G also. First option is the correct answer for this question, and thank you.